Welcome to the Welding Spacecast, where the universe comes to learn about Chapter 9. Alright guys, let's work on some stick electrodes and selecting electrodes today. Okay, so we're going to learn about a couple of different things. So the first thing is understanding how it works, okay? So we all understand in a basic principle that a current is created from the machine and it throws through a circuit and it melts the rod. But really what's happening? So if you look here, this is the electrode that's in the middle. That's the solid wire, or the solid rod, okay? But around it is a coating. This is called flux coating. That flux coating does a couple of different things. It helps give us alloying elements. It helps create slag, and it also gives us a shielding gas to protect our weld, okay? So these are some of the things it does, and it's important for us to understand. So the American Welding Society has, and they're probably this year was their 100th year. What they have is a classification system and a specification system. I want you to imagine a big barrel, okay? And on the outside of that barrel it says A 5.1 or A 5.5. That is a specification, and inside this barrel is E6010 or E7018 or E7024, and these are classifications, okay? So the barrel says A5.1 is all electrodes for stick electrodes for mild steel. A5.5 is stick electrodes for alloyed materials, okay? So if we have an E6010, that is a classification, and it goes in the barrel for mild steel electrodes. So then manufacturers have to go along, if they're going to say it's an E6010, whether it's from China or whether it's from the United States, they still have to go along with those specifications and making sure it's the same composition as the classification is identified. Okay. Now, this classification is an abbreviation or a shorthand. Okay. It tells us all about the rod that it's stamped on. If it's you can't see a stamp on the rod, do not use it. I could be handing you a stick of dynamite. You never know. Okay. So let's understand how it works. The first letter for E is electrode. If we see an R or an ER, it says the electrode or rod. E tells me electrode, that the electricity flows through it. Okay. Now, the first two numbers, okay, they tell me tensile strength. Okay. Tensile strength, it would be 70,000 pounds of tensile strength. That means how strong is it when I pull it apart. Okay. The third number, this tells me the position I can run it in. So the number 1 tells me flat, horizontal, vertical up, vertical down, and overhead. Okay. If I have a 2 here, it would be flat and horizontal fillet only. And if I had a 4 in this third digit right here, I can do flat, horizontal, vertical down, and overhead. So it's telling me specific how this rod can be used. Okay. Now the last one, the last number, tells me type of coating. That tells me the flux coating, and it also tells me current. It tells me what polarity I can run this rod in. And it's very important that we run it in a correct polarity in order for it to work correctly. And I'll be giving you guys a handout on this, and that'll make things a little bit easier for you to understand how it works. Okay. Now this number here is going to tell me about impact strength. How strong is it when we hit it? Okay. These two numbers, it'll have an H, and it'll either say 4, 8, or 16. It says how much hydrogen is in this. Because hydrogen is not good for our weld, we want to know that there's as little as possible. And this R tells me that it met the requirements of a moisture test. Okay, so I usually want an H4R. These aren't quite as important as this number here, This gets more into like specifications, especially if you're like the job supervisor or the engineer. Okie dokie. Now, here we go. We're going to talk about some electrodes. Now, I'm going to give you another handout on this one too, but let me explain to you. What they have is they're called F groups. F groups way back in the day told the welder how difficult it was to weld with a particular rod. And they grouped these rods together kind of by the same type of characteristics and the same type of flux coatings. So they have all the way, I think, up to F91 or thereabouts. So F1 was one of the easiest, F2, F3, so it becomes harder sequentially, okay? I'm going to give you a paper on this, but when we say EXX, that XX is in place of our tensile strength, okay? And then we have in the third digit a 2. What is it telling me? Flat and horizontal fillet only. All right, and then we have a 0, a 7, or a 4. So it's telling me these coatings are iron oxide, iron powder oxide, iron powder titania. And these also tell me the polarity. Okay, shallow to medium penetration, high deposition rate. It's going to have easy slag. Usually these are known as jet rods. These are going to be for production welding. Okay. All right, now, so that's F1. That's the fast fill group. It's going to fill quickly. High deposition rate means I can put a lot of weld down very quickly. Okay, the next one, F2, fill freeze. This means it will fill relatively quickly and it will freeze quickly. It's kind of best of the both worlds, okay? So that's an EXX12. So the 1 is what? All positions. And then there's a 2, a 3, and a 4. Titanium sodium, titanium potassium, iron powder titania. DC electrode negative, AC, AC-DC. So most of these can run in almost all of them. We're going to have shallow to medium penetration, okay? Low spatter. These are going to be mostly for sheet metal and thinner materials, okay? F2, okay, that's fill freeze. F3. F3 is a very important group. It is called a fast freeze group. That means my puddle freezes very, very quickly. And notice what's in here, guys, an EXX10, 6010, 7010, 8010, 9010, 110. It doesn't change the only thing it changes is how strong the wire is on inside, okay? This is cellulose sodium. It can only be run on DC electrode positive. We notice 0, 0, electrode positive, okay? Now, what does this rod do? This rod is a very deep penetrating rod. It doesn't put too much in. We're usually going to use this for pipe welding. We're going to use this for pour fit up or something that has an open root that needs to close quickly. Otherwise, if we used other rods, that would hang down into our pipe. But the other thing that this cellulose sodium is, I don't know if anybody took chemistry in high school, but what is NaCl? Sodium, right? Well, if you added sodium to water, what would happen? Well, if you're one of those bad kids, you actually threw a little piece down the toilet and it would explode the toilet. Yeah, I know. Okay, anyways, so what's happening is that when we're using this flux, it's actually digging it. It's pulling out anything. So it's usually good for rust, oil, paint, and all sorts of gooky stuff. And it pulls it out. Okay? And it pulls it out into the slag. And then it allows us to fill it up. Okay? So that's our F3 group. That's a fast freeze group. Okay? We have one more other group. It's called F4. That's a fill freeze. It means it fills relatively quickly and it freezes relatively quickly. Kind of that 50-50, okay? That's my 16, 18, and 48s. So this would be a 70-18. These are usually low hydrogen potassium, low hydrogen iron powder, low hydrogen, okay? These are usually run on DC electrode positive, okay? These are medium penetration, medium to high deposition. We're going to use this on thicker sections and good for high sulfur and high carbon steel. And we want to make sure that because they're low hydrogen, that we actually keep them warm so without getting moisture, and we can run them in all positions. Okay, pretty good, right? All right, so we'll take a quick break and come back.